Don't forget that we still have our Twitter going. Lots of conversation on Twitter using the hashtag AWE2016. Anybody use Snapchat out there? Have you used our geo filter? What? Post it on Twitter because I'm not on Snapchat so I can see what it looks like. Is that a little bit ironic? Okay, imagine Siri having a pair of eyes that can read your bills and teach you how to read Chinese. Our next speaker is CEO and founder of Waygo, a visual translator application. Ryan will share the implications of mobile devices being able to read written languages like humans do, including how wearable computers can help us in everyday tasks where reading is required. Please join me in welcoming Ryan Rogowski, founder and CEO of Waygo, to the stage.
Yeah.
Hey everyone, my name is Ryan Rogowski, the CEO of Waygo. We build instant visual language recognition technology for offline devices. So I'm going to share with you guys a little bit about my vision on how I feel this technology will change the world over the next 5 years. But I'll start out by giving a little bit of background about myself and why I might know a few things about this stuff. So I went to University of Illinois. I studied electrical engineering and linguistics. And then I went into doing computer vision technology. So I was doing research in video copy detection, object recognition, and then eventually text recognition and OCR. And then during a lot of this time, I built some games on iPhone and Android. A lot of them failed. Some of them were OK. And then I went on to build some other cool technologies like Waygo Translator app. And I just want to say, if none of the technology stuff I say makes sense, then you should at least listen to my tips on learning Chinese, because I did manage to learn that. So what is visual language recognition? Well, basically what I mean by that is a combination of text recognition and OCR to find text in the real world. A lot of academics say that OCR is a solved problem, and it is to some degree, but not in the use case that we see in many real-world situations. So if you're looking at signs in the real world, or you're looking at receipts or historic degraded text, or even handwritten forms and notes, these are all cases where OCR doesn't really work that well. And it limits devices' ability to see and recognize text and help us in the real world. So how, what is hard about this problem? Well, one, when you're looking at text in the real world, there's a lot of noise around. So you could take a look at the text here. We find it right away. But a computer may think that pieces of that text are actually mistaken for objects in the image, or they may actually mistake objects for text in the image. And there's a lot of complicated processes to actually finding these texts and labeling it. What's also very hard is when you're looking at technology or at text, and it's either handwritten or scrunched together. It could be really crazy fonts. It could be really bad third grader handwriting. These are all challenges that make it very hard for a computer to read text like human beings. And so there's a lot of effort that you have to put into figuring out how to segment these characters and really parse them across an image. And what makes it even more challenging is if you want to do it in real time so that computers can make real-time decisions, this is actually an even harder problem. So where are we today with OCR? Well, a lot of you guys have used technologies like this before where you scan in documents and then basically you're able to recognize all the text on an image or a form and then index it. So this is a really common use case and it's pretty successful. A lot of companies use this to optimize their internal processes. It's pretty well solved, and the main reason that it's solved is because it has very limited issues concerning the problems we talked about with finding text in images with noisy background, as well as identifying texts that have clearly printed fonts and whatnot. But now, you may be wondering, well, OCR sounds cool and everything, but how does it relate to augmented reality? What what do we need to do to be able to see this type of character and visual language recognition technology be impactful in augmented reality use cases? And that's what I want to talk about today. So where are we with real-time language recognition? Well, I want to first highlight a use case that some of you may have seen, some of you may have not. It could be seen in Google Translate, it could be seen in the Waygo translator app, but it's pretty amazing. So imagine if you're pointing at language text that you don't understand, and visual language recognition could find that text and tell you what it means. So this is an app in the App Store. You can download it and try it out. It's very cool. If you go to a foreign country and travel and really want to understand when you're going shopping or eating, things that you can do and see. Now, foreign language is one really cool application of visual language recognition. But another one is, how many of you studied calculus or studied math back in the day and you just weren't very good at it? So you wished you had that robot or a teacher who could be on your side and teach you how to do it. So there was recently a really cool visual language recognition app that launched called MathPix, which basically allows you to point your phone at certain text and see the equation solved in real time. So this app climbed to the top of the App Store ranks super fast. As you could see, it's a really impactful way to look at visual language recognition in real time and help people in a way that exists today. So another application is, well, imagine if you were trying to help your administrator with really mundane tasks that take a lot of time, like recognizing receipts or filling out forms and indexing quickly. Well, imagine if you could use visual language recognition to enhance that process. What we're doing here is just basically in real time extrapolating the vendor and pricing information from a receipt that could be used for expense report management. And basically the goal is, well, how can our devices today help us with these painful processes that we so much hate doing on spending hours of time wasted on doing these things. And another last really cool application that's already augmented reality in the real world using visual language recognition is dictionaries. So you'll see a lot of dictionaries start integrating this type of feature into their apps, but imagine if you're reading and paging through books and you're having to look up words over and over again. Well, this type of technology can help you see the definitions instantly in real time and even add visualization. So let's say you're wanting to know what a squash looks like as a third grader. You could use these types of technologies in combination with augmented reality to enhance that experience. So now what about the future? What are some cool things that are up and coming that are beyond what we can do with mobile today? So I want to talk quickly about cars, robots, and wearables. So cars is an interesting one. I'm not sure how many of you guys own Teslas or have tried them, but it's pretty amazing that you can summon your car basically like a valet so that it can appear at your doorstep or the entrance of a restaurant. But for cars to really be able to drive like humans, they not just need GPS, but they need to understand environments in real time. And that means reading signs. That means identifying pedestrians. So visual language recognition will play a key role in basically finding these signs, reading them, and helping a car make a decision where if it sees a street sign, it can match that up with the maps and the GPS navigation and make sure it's doing the right navigation in real time. What's another amazing application of visual language recognition has to do with robots and drones. There's already some pretty cool companies that are working on these type of related tasks. So there's this company called Tally that's built a prototype. Basically, it has a robot in a retail store that's helping with the mundane task of shelving store materials on basically the shelves in a store like Jewel Osco or Myers or Kroger's. So basically, these robots, in order for them to work, they need to be able to identify shelving. They need to be able to verify pricing. Because how many times have you went to a store, bought something where the price tag was incorrect, and if you didn't get the benefit of the doubt, you ended up paying twice as much for cereal that you maybe didn't even like. So robots can play a key role in a lot of these mundane tasks, but they have to be able to understand language in a visual way. I also want to talk a little bit about what happens for people who have been visually impaired. So this may hit home for some people, but with the technology we're building today, we can really impact the life and health of a lot of people. There's this project called Assisted Vision in Smart Glasses that's out of University of Oxford. They're using an Epson Mevoria to help enhance eyesight. But this can also allow people to read language again if this was something that they weren't able to do, or something that having lost sight after a traumatic event, you could allow someone to be able to read text like this. And another related application is this really amazing project out of MIT Media Lab. Basically, they built this little device that's using OCR and visual language recognition to allow people to rub their finger across text and be able to hear it in audio in real time. So this, as you can imagine, can help people read books. It can even help people in scenarios or situations that aren't friendly for visually impaired people. Like here at Santa Clara Convention Center, I still have yet to see any Braille anywhere. Whereas if someone was able to use a device like this, or a robot assistant or eyewear assistant, they'd be able to navigate the world just like any other person. And what I want to end on is something that's pretty cool, and maybe some of you guys have imagined this before. But I want to show a little really hacky demo that we put together at Waygo using Google Glass. And as many of you know, if you've tried it, there are a lot of limitations to Google Glass' ability to use the camera or do truly augmented reality tasks. But what we did is we built a prototype with our technology doing Japanese and Chinese translation, and we just wanted to see what it would look like and take a glimpse of the future. So basically, this is just a quick demo video we recorded where basically I'm wearing a Google Glass, I go up to some Chinese, and then it appears before my eyes. And I was actually able to take this device on my first trip to Tokyo, and it actually gave me chills down my back, because even though I got lost in Tokyo Main Station for 2 hours, and it was still kind of a hard experience dealing with the language, just using this in its limited form gave me a glimpse of what will be possible in the coming 5 years. And it's just so exciting that things like this are coming and on the verge of happening. So my name's Ryan Rogowski from Waygo. If you're interested in text recognition, OCR, or visual language recognition, come visit us at our booth. We have an SDK to help developers build applications. We're building our own applications with the technology, and we'd love to talk with all of you. So thanks for having us.